Is it happening yet? Yeah, we're live.
We are live.
Send.
Boom. Retweeted. Okay.
Just double checking that the volume is working. Just 1 second.
Okay.
Yep, volume is working. I can hear it on my side.
All right, let's get started.
Yes. Awesome. Well, welcome everyone to the IBC live stream with the Game of Zones team. And today we've got Agoric on the chat as well. What's up, Dean and Mark? How you guys doing today?
Good.
Awesome. So I think
Dean, we cannot hear you.
Your audio is not working.
There we go.
Boom.
See, that's Jack. You look different from the last time I saw you.
I just, I did something with my hair for once.
I know what you mean.
Yeah, and Dean, looking solid, clean shaven as well. So I think that the plan of action today is to, I was going to give a quick relayer demo and sort of talk through that piece of it. And then Dean is going to build on top of that demo with some of the stuff that you can do on top of IBC with Agoric. So
before we jump into that,
yeah.
Just heads up, if you haven't signed up for Game of Zones yet, registration is going to close on Saturday. So make sure you get your team and all of your information into us. Over the next week, we'll be reaching out to people. We have some information like RPC endpoints we'll need to collect to make sure that we have a functional dashboard. But don't miss the opportunity to sign up because it looks like we're going to have a really great competition this year.
Yeah, it's how many folks do we have registered so far, Jessy?
I don't know if we should tell everyone, but it's a lot. It's
a lot.
It's about 50% over what we expected. So
yeah.
It should be a raging good time this year.
And probably, I will say, the last couple of days are generally the most active in terms of registration. So it's going to be a really good crew and very excited to really battle test IBC this year.
Yeah, so I guess to make sure that you are ready to get going on Game of Zones, Jack's going to go ahead and show us what he's been working on with his relayer, which is basically one of the most important parts of the software you'll be using throughout the competition.
Yeah, I think that it's, the way that most people are going to learn how to interact with IBC for the first time. And, once you sort of understand how the relayer works and you're able to set up that infrastructure, then building more complex application protocols and stuff becomes much easier. And I think the relayer is basically meant to help you conceptually understand it so that once you get up into Agoric land in this JavaScript VM that they built, which is really awesome, doing all these complex contracts and being able to work cross-chain very easily in that environment, it is going to help when you're troubleshooting to be able to debug the various connection stuff, and the relayer will really help there. So let me just go ahead and pull that up now.
Yeah, one of the funny things about the relayer, just for context, it's like routers in the internet. It's incredibly crucial. It's really important. It had a lot to do with the evolution of being able to stitch all these machines together. And at the end of the day, most people, kind of plug something in they got from the store and they're done. And but we're right now at the stage of making all that work, and so everyone out there jumping into Game of Zones is helping to sort that part of the world out, so that the rest of the millions of developers out there don't have to.
All right. Well, thank you for that intro. So the relayer is a command line only application. So please be comfortable with the command line. If you go to github.com/occlusioninc/relayer, and we'll drop a link in the show notes here. There is a README that will walk you through this demo that I'm about to show you. And the command line tool itself, RLY, has some very verbose help text. So if you find yourself getting lost, just dig through the help text on the relay command, and it should get you where you need to go. So let me first start by clearing my configuration. And the first thing I'm going to do is spin up 2 Gaia chains. So this is just to simulate relaying between 2 individual IBC chains. And, Agoric will be an IBC chain as well. This is just sort of the most simple version of this demo here. If you'll notice, I'm on a branch here. All this will be merged to master, and please use the master branch on the relayer. That is the most up-to-date version. And then also, if you're going to test using Gaia, the branch there is IBC alpha. Okay, so we have a couple of Gaia instances running. There are logs. You can see blocks getting produced. Great. Next thing I'm going to do is configure the relayer. And there's a few different relayer configuration steps, and I'll kind of talk through them as the script is running. To be a relayer, the first thing you need is a like client for each chain you're going to relay between. And this is basically in order for you to be able to prove data coming from the individual chains, as well as the relayer needs to submit headers for, let's say, chain A to chain B and vice versa. So those like clients are critical for that. Another thing that you'll notice here is these keys. The relayer does have active wallet functionality for each chain that it needs to relay against. So you need keys with funds to pay for fees. Then there's also some local relayer configuration. RPC endpoints for the individual chains, and then some information about the paths that you're planning on relaying between. Okay. So one way to check this is to look at the list of chains that you have. I just have IBC0 and IBC1, and you can see that we have like clients, a path configured to relay between them, keys for each of those, and if we query the balance for IBC0 and IBC1, you can see that we have tokens ready to go. So in order to create a connection between 2 chains and send data over top of it, there's 3 primitives that you need to create: clients, connections, and channels. Clients are what I was talking about earlier with the like clients and the headers on each chain. And the command there is demo. So I'm going to, as this is running, I'm going to kind of talk through it. So you can see these clients getting created, and this is committing one header from IBC1 over to IBC0 and vice versa. The next thing we do is create this connection. In the connection, Dean, correct me if I'm wrong here, this is the sort of authentication step where each chain validates that the like clients on the other chain are valid.
That's right, and keeps in sync with them. Yeah.
Yeah, and you'll notice that these clients are periodically being updated throughout this process. This is because we're including new data on one of the chains that we need to go prove back on the other chain. When we're creating that connection. Now, you can see that the connection's created. And the next thing we need to do is the channel. And channels provide ordering semantics and routing semantics, i.e. Is the data ordered or unordered? And then as far as routing, where on each individual chain do we want to deliver this application data to? And
channels are the main thing that application developers experience. They're like TCP connections, where I've got, it's an open sequence of packets going back and forth. I can have multiple channels open, and those are just independent streams of packets going back and forth, where above that is the application layer that is app specific.
Yeah. So, and if we look through the various primitives here, we can query the clients on IBC0, see that we have this client for IBC1 here. We can also query connections and channels. We can see that this connection is open. It's ready to relay across, and this channel is also open. We've created an ordered channel. Right now, the relayer supports ordered channels. I'm working on unordered channel support, as you can see on this branch, so that's coming very soon. And then what's important here is that we're relaying to the transfer port. And this is sort of the canonical, we want to transfer tokens from one chain to another. I think Dean's going to show us another application after this.
And just to be clear, transfer there's nothing special about that word. That's just the name of the port for the name of that particular protocol.
Yeah, exactly. And you can think of this as sort of the port on a Linux machine. You know, like Gaia listens on 26657. In IBC, the transfer module, which handles these transfers, listens on the transfer port. So I'm going to show you a couple ways to do this transfer. The first one I'm going to show is just completing the transfer all in one command. And then I'm going to show how the relayer is going to work sort of in the canonical operation. So we're going to transfer from IBC0 to IBC1. This is the amount of tokens we're transferring. Those tokens originate on IBC1, and we're going to use the address that the relayer controls over on IBC1 to send those tokens to. All right, so that completed successfully.
So the dollar open paren relay to whatever, is that the relayer is actually parsing that, or is that something that's just happening in your shell?
That's something that's just happening in my shell. Okay. And this is just the, each chain has a set of keys. And you can see on IBC1, we have this key called test key. If we look at the chains show IBC1, if we look at the configuration for IBC1, we can see that that test key here is the one that's configured. So this relay chain's address is just a little affordance to pull that address. And basically what we're saying is we want to send tokens over from IBC0 to that address on IBC1.
Every time I see your relayer, there's some new cool bit of functionality. So, you know, by the time Game of Zones is done, it's going to be able to do all sorts of stuff, even more than this. So.
Yeah, absolutely. So all the cool stuff. So, you know, with this balance command, it just defaults to using that key. You can also manage multiple keys with the relayer and query those balances individually. I've just tried to make it, in the default case, really easy and very explainable what's going on. So we see that we transferred those tokens successfully over to IBC1. Now, as a user, you know, like let's say I'm on IBC0 and that's where I do most of my work. I don't want to have to go transact over on IBC1. So I'm going to rely on somebody relaying over one of these channels, and all I'm going to do is send the transaction on IBC1. And in this mode, the relayer is sort of listening for events, both transaction and block events from IBC0 and IBC1. And whenever it sees events that match the pattern, i.e. an IBC transfer message or anything IBC related that we need to relay over this channel that we've created, it's going to just go ahead and complete the rest of the transactions. So as a user, I would just tx raw. We're just going to send the send transaction, and then the relayer is going to take care of the rest of it. And we're going to go from IBC0 to IBC1 again. Send some N0 token. And again, use that affordance there. And you can see we just sent that transfer message, and then we go over here. The relayer saw that. It sent the receive message over on the other chain, and then it's
Jack,
acknowledged that as well. Yes, Mark.
On that pane, can you make the font larger?
Yes, absolutely.
Okay, thank you.
Is that viewable?
Yes, that's fine.
Okay. So what happened was we sent the first message. So this is every packet takes at least two messages, one on the sending chain and one on the receiving chain to complete that IBC transaction. And here, as the user, we're just sending that first message, and then the relayer takes care of the receipt message and the acknowledgement message back on IBC1. And if we query the balance on IBC1, we will see that those transfer tokens showed up. So this is sort of just the canonical way to use the relayer and the most simple mode of operation. Once you have that relayer listening to events on both of those chains, sending arbitrary application data over top of it is possible. And I think that's what Dean's going to show us here today.
Yeah.
Maybe I do see a couple of questions here in the chat. Maybe we answer those first and then jump over to you, Dean. Is that okay?
Sure, absolutely, of course.
All right, so what will be the role of the agoric token in DIBC? I think maybe we get to that one later, Shojin, after Dean's demo here. And then Vitalik asks, to run a new zone from scratch for the GOZ purpose, what are the recommended infrastructure requirements in terms of computing, RAM, storage, speed, and size? I think for testnet nodes right now, I'm running 2 cores, 8 gigs RAM for a testnet node, especially because you need to expose an RPC point. Having a slightly performant machine to run that on is something I'd advise. Zaki, what are your thoughts on testnet hardware configuration for users?
So, sort of standard Gaia hardware, 2 cores, 8 gigs of RAM will probably be fine as kind of MVP. When you get into phase 2, and we're talking about throughput, more performant hardware, if combined with the right Tendermint configuration, might get you the ability to send and receive more packets. So probably something to keep an eye on.
Yep. Hey, Zaki, we seem to be stuck on your GitHub, and we're not seeing the screencast.
Look.
Is that the entire time?
No.
Okay.
I think that this was after I finished with the demo. So,
Okay, good.
yeah.
Did I hear something that we'd get in trouble for if the FCC tuned in?
Nice. Well, Dean, do you want to take it away?
Well, I figured that we'd step back for a few minutes and talk about what the point of all of this was.
Yes, absolutely. I think that's a great way to start.
So, for people who don't know, Agoric was founded by people who've been working on this stuff for a long time. So Marcus here, our chief scientist, that really seeded some of the key ideas of software agents creating and participating in markets back in the Agoric Open Systems papers in 1988. And so some of what IBC is doing is it's combining, our vision of distributed computation and enabling distributed smart contracts and cooperation with the best practices for light client validation and interchain pegging and those kinds of things. And IBC really kind of boils those two together and produces something that lets us achieve that vision that Mark articulated a long time ago in the context of blockchain communication. So before we dive into demos, I thought it might be useful to talk a little bit about from Zaki's perspective, or the questions about how IBC got started or where it's coming from. That might be useful to touch on. So
yeah, I think that's great, and the work that we've done on IBC is substantially based on the work that you guys have done on object capabilities for the last couple of decades. So yeah, please.
So I'm curious, Zaki, I know that you mentioned finding the eWrite stuff that Markham had done. What problem were you trying to solve when you stumbled upon that? And then we'll go from there.
Yeah. Okay. So let's talk about it from my experience and point of view. My experience was so there was this group of people who had this obscure hobby, which was scalable public blockchains in 2015. And I was kind of between a number of different teams. Like I had the Dfinity people sitting on the other side of the desk from me. I had the a little co-working space in Mountain View. I had I was friends with Vlad and Vitalik, and we were talking to them about sort of the Ethereum sharding vision, which people don't really realize, but goes back to 2014, 2015. And we were talking about we we're thinking a lot about what like is now sort of called the adaptive corruption problem, which is what happens when a blockchain gets taken over by a set of evil actors, and how do you deal with that in a sort of multi-chain world, in sort of any sort of multi-chain construct, and the techniques that we were looking at the time for how do we actually minimize or mitigate this problem in a sharded blockchain were deeply unappealing, and we're just starting to see like the first inklings of any of those ideas actually being deployed into production, and it's like almost 5 years later, which is kind of like what I was thinking at the time, which was this idea like and it's like have a random beacon, have this shard chain, have these fraud proofs. All of this stuff is about solving this, like you build all of this complexity and it's about solving this one problem, which is like, if I build a system in which evil, like malicious actors taking over one of my chains breaks everything, I have to use like in these incredibly complicated mechanisms to make sure that never happens. So where I came across Markham's work was really looking for like an alternative set of abstractions, an alternative way of thinking that would push this problem of how do you deal with a blockchain that is, potentially churned against the interests of one of its users, in a way that like doesn't require, that like sort of pushes the problem up a couple of layers and allows for the top level software ecosystem to deal with it, rather than just trying to make this whole thing sort of impossible, which is the technique that so many other chains have taken. So that led me to Markham's work, and sort of seeing the sort of missing piece of this sort of Agorix paper, which was like public BFT computation, and sort of taking Jay Kwan's work on public BFT computation and the Agoric work, that to me led me to Cosmos.
So to expand on that, and I'm very glad you mentioned the BFT, the fault tolerance to Byzantine behavior, because I want to contrast two different philosophies of fault tolerance and align them with two different philosophies of what decentralization means, and how with blockchains plus IBC, we're bringing both of these visions together. The blockchain, the single blockchain, this vision that where each blockchain project is constructed assuming that blockchain should be the only blockchain in the world, that's decentralized in the sense that there's no one actor that can corrupt it. You have to get a large collusion in order to corrupt it. But it's centralized in the sense that everybody has to agree on one set of decisions. Everybody has to agree on one architecture. There is this decision-making and governance bottleneck. I want to contrast that with the decentralization that we've seen in the internet and the web, where you just have a bunch of loosely coordinated separate parties that don't trust each other, but are trying to interact cooperatively. And if any one of them go bad, well, they have gone bad. Some things have gotten damaged, but the rest of the system goes on. So the first approach is fault tolerance by fault masking, by trying to make it the case that the fault never becomes visible. The second one is fault tolerance by fault containment, where some parts of the system might go bad, but the system as a whole, by virtue of competition, reputation feedback, and simply diversity of experiments, the system as a whole tolerates any one component going bad. And the key vision that we approached creating smart contracts with before blockchain, that we're now taking into the world of blockchain, was very much the loosely coupled decentralization, where there's no one decision that everybody has to agree on. that we're just trying to agree on protocols so that we can talk to each other and cooperate, but the protocols have to be designed to support mutual suspicion so that if you start acting badly, then I can be protected from your misbehavior. Then the world of blockchain happened, and we realized that there are some particular institutions in particular money and certain large-scale coordination points where having the fault masking, having a single logical institution that internally has such strong controls that it's unlikely to get corrupted by one bad actor is very valuable for some points on the network. But you still want the network as a whole to have a diversity of those things and to have it be the choice of any participant what they're relying on for what vulnerabilities they take on, and what kinds of cooperative arrangements they engage in. So IBC is treating each blockchain like a separate node on a network, and is protecting each blockchain from every other blockchain so that they can be tolerant of a blockchain as a whole going bad.
So,
Dean, you're muted.
I am, yes. Let me try again. Just a quick follow-up on that. You know, that it's easy to think about IBC as connecting the two blockchains, and it does. But from a trust or security or whatever point of view, it's actually finer grained than that, where you could have a process or a contract on a blockchain that is relying on something on some other blockchain, but no one else on either blockchain is vulnerable to the other side, right? I might my application might trust the bank on some other blockchain, but that doesn't mean I have imposed that trust on the underlying infrastructure that I'm running on. I just happen to be relying on it and no one else needs to, right? And so you've got very fine-grained ability to have reliance and separation of concerns and protections and so forth. Now, I know you have a bunch of questions here, which I think Jack is probably looking at. And then we can show some pieces of this.
Yeah, not a ton of questions. Just another question around disk space on Game of Zones and hardware requirements, which I will answer in the thing. So you guys just go ahead and keep talking over.
Let me show some of the higher level stuff that Mark was talking about. So I'm going to dive into screen sharing here, if I may. And I'm going to go from the sublime of the relayer network to our alternative to Hello World. So what's a smart contract, right? It is not, code running autonomously on a blockchain. It is a much higher level concept than that has existed since Nick Szabo put all the pieces together and characterized exactly what it was a bunch of people were doing that was going to be valuable going forward into the future. And it is a contract-like arrangement between parties where the software is enforcing the terms of the contract. So it's a contract-like arrangement expressed in code. Now here, I've got a very silly one such thing where I am interacting with what we call our encouragement bot. Can you see the encouragement bot? Is that big enough? And this is, consider this to be Hello World. So it is not intended to be sophisticated by any stretch of the imagination. And I can simply do, hey, I'm feeling like I want to hug because I've been isolated. And it says, I don't know if you can read this, encourager says, you're doing great, right? Now, all of that happened going over to a smart contract that ran, here's the get updates and the various interactions. So it went by sending this message to a web application running in the cloud being, my machine here, but for real applications like a Uniswap-like thing or a Compound or a, whatever it is, or a decentralized StubHub, those would all be running on some web service and talking to a smart contract on the blockchain. And so this is talking to a web service, talking to a smart contract on the blockchain directly. So there's no IBC involved, but I'm just doing this kind of thing where I can say, now I want a different, I have to say, yes, thank you for telling me that I'm doing great. Now I'm going to give them a tip from my budget. Here it says, please approve your tip. That sends me over to my wallet, and it has proposed, let me shrink this just a tiny bit so you can see. It is sending something off to the blockchain, which I think I accidentally paused. There we go. And here in my wallet is a transaction that I am asked to approve, because after all, this is a wallet. I have to approve spending $1 to get the encouragement, or a coin, and now I get the encouragement. That approval goes back to the blockchain, and it shortly will wake up. And if I go to the blockchain, you can see it's spewing out blocks here, and maybe I broke something. Or I have to go back to my app. And so that when the encouragement, you can see the count appeared here. I had something that was suppressing pop-ups, but this is a simple contract, right? Let me now take that contract, and I'm going to enhance it with IBC, because after all, that is what the Game of Zones world is for. And so this is, if I actually look at the code of that contract, it's done as a smart contract in JavaScript. So the way smart contracts in JavaScript on our system are built are, let me scroll up one more line here, is that we have a make contract function. You just have a module that has a make contract function that takes as an argument access to the underlying contract framework, where it can get offers and ask about the current status of prices and rearrange money and various other things you can learn about on our website. But down at the bottom, it has a normal JavaScript program, and it's just doing, it has a method that will be invoked here, this hook here, whenever an offer comes in to say, hey, here's an offer. And if I was an auction, I would add that to the set of bids in a sorted order. And when the auction closes, I would pick the top one. In this case, it's going to come down and check whether it has a tip. And if so, it's going to return, it's going to do various things. But fundamentally, it's going to come up with an encouragement that if I didn't give it a tip, it gives me the basic encouragement, hey, you're doing great. And if I did give it a tip, it will give me the premium encouragement saying, oh my God, this is wonderful, right? And we'll sort of see that. And then down at the bottom is the result of returning all of this, which is in our smart contract framework, which I'm not going into very deep, obviously, but it returns an invitation to submit an offer and an object that anyone who's got that can interact with, anyone who knows about the contract can interact with, in order to do things like, hey, invite me, or get a free encouragement, or let me know when something's changed, or various other public services on this smart contract. And so this here is sort of the core of, here's the public face of a smart contract, here's what I want other clients or other contracts to be able to interact with, and we can do it all through this. Okay, so why am I showing you this? Because the enhancement of that, in order to support IBC, was just in my deploy of this contract, I say there's an IBC port, and I want you to set it up and make it available. And this is just setting it all up, so when I deploy this contract and make an instance, I give it access to IBC. And then in the contract itself, in IBC, great, get access to the IBC port that it was configured with. And now this looks like a pretty straightforward network interface kind of thing. Let me make this just a little bit bigger. Because this is in some sense, almost the punchline here. On that IBC port, I want to add a listener such that whenever someone, yep.
One more bigger, please.
Sure. I can do better than that. How about 2 more bigger?
Good.
Great. So, so this looks a lot like a TCP thing. On this IBC port, add a listener such that when a new connection comes in, here's what I want to do. And what I want to do is set the current message to that premium message that I mentioned, and return the handler for that, so that on open, I'm going to do this work. So when the connection is opened, and when I receive a new message, I'm going to do this stuff. So when I receive a new message, assuming I'm still active, that's the exit if I'm not active, assuming I'm still active, send that message up here that I said, let me scroll up just a tiny bit, the premium message up here, and then change the message to basic. So I only get the premium message once, first come, first serve, and then everyone after that gets the basic message. And this is the entirety of a JavaScript handler for an IBC endpoint, which is take this back. And so whether this has got the bytes, and whether it is parsing that with a standard JavaScript library for protobuf, whether it's taking it as a JSON blob, which is what the transfer protocol does, whether it then takes that apart and analyzes it, filters some of them and calls another handler or does whatever, this is the place where people can innovate and rapidly build new contracts and send back appropriate responses or return ACKs and NACKs in the IBC protocol. And here, this gets invoked when a message comes in on a channel over IBC. This gets returned as the ACK. So if you throw an exception, it'll return an exception. If you return a result, it'll get marshaled and sent across. Okay, so what does that look like? Well, I am in a running chain. As you can see, it's continuing to spit out blocks. This is my, wait, where's my other web host here? One of these guys is, I have, as you can imagine, there we go. So that's the block itself, and I have many windows open. Somewhere here is the window with the there we go. This is the one. That's my web service. Okay, good. I just wanted to make sure that was up. So now let me get me a command window here that is not just illustrating what's going on. And I will go here. Sorry, I'm trying to find the right window for you to get at the hazards of giving demos is, of course, you end up with, oh, there it is. It was just hidden in this window here. So let me bring that up and make it a little bit bigger. Okay, and what I'm going to do is I'm going to go, that git change I showed you is another branch, so I'm going to go ahead and git check out DIBC. So this is taking my encouragement app that I have the source code here for that you saw, and now you can see a little bit bigger. I'm checking that out, so I just get a few new files. If I go here, I should be able to see. Am I in the right place? Then I have that I have the IBC stuff. Is it there? Git status. All right. Okay. So I now have that there. Let me now go and do a deploy of that contract. So that's going to deploy the contract. So this is just the agoric command for creating new apps and deploying them. It's going to deploy execute the contracts deployment script and execute the APIs deployment script. So that will deploy both, and it is so uploading the contract to the service, turning around and with that author's key deploying this contract, and then and all of these go through several round trips currently goes through a lot more round trips than the real production version needs to go through in terms of blocks, simply in order to make the deployment code easier to document and illustrate to people. Much of our architecture for doing distributed systems that comes from Maya and Markham's work over time is about doing pipelined distributed messaging and high performance pipelining between machines and so forth. We are not illustrating that here deliberately. Let's see, let me make sure I didn't accidentally. One of the hazards of Windows boxes is, of course, when you click in a window, okay, chain is moving, this machine is moving, and, are we done? Yes, it is stepping forward very slowly through this process. Okay. You can see it's doing just a little bit there. I must have set the chain. I probably launched the chain with 5-second blocks And no, we're going. All right. It'll take just a minute. So,
Did you launch it with slightly faster blocks?
I thought I did, but I'm guessing I did not.
Honestly, I don't mind because this is the most gorgeous screen of like movie theater hacker text I've ever seen. I'm falling when somebody asks for help in a hacker movie. I'm just gonna say, call Dean. He'll make you the best screen ever.
Yeah.
One thing. Lines have to be vertical though.
They can be any which direction.
Okay.
A whole new dimension these days.
I know why this didn't update. It's because I had. All right, let me close this.
Dean doing it live. So one thing to note just real quick about the chain speed. A lot of the demos that you're seeing, because the chains are running locally and we don't really need to go over the open internet, in the rounds of communication for the validators are all very tight. Turning the speed up on those chains is really easy, and it makes for nice, quick demos. Block times on Cosmos public chains average around 5 to 6 seconds, whereas in these demos, you're seeing block times around 1 second. So, you know, all this stuff works on the public chains. We've got nice retries on all this, and it's great, but your experience may be slightly slower than you're seeing in the demo.
Right. Yeah. Yep. And so, okay. And so now it's woken up again. I just killed. So one of the things I did. The chain is still running in the background, right? The chain is fine. But what I did is this Ag Solo machine had hung because I had something that took up a lot of memory and probably choked it earlier. And so what it's doing now is I just killed it, right? Welcome to reliable service. I just shot it in the head and started it over. And what it does, and this is our model of computation semantically, is it's just replaying all events from the beginning. And so it is deterministic execution of JavaScript computation in this VAT that is running. And because of that, it can replay all events from the beginning, which of course this was from last night, so there's a fair bit of events to replay, and this thing does not have all the optimizations for that turned on, but it replays all events from the beginning and gets all the same results, which means it gets back to exactly the same state that it was in before. And so, you know, but I kicked it. Now we'll see if I can catch up with it, and that things will be a little bit happier. Yeah, see, this is the sort of speed that I expected to see as it's going through. And now it's running through, and it is exactly the same server as I had before. When I did that originally, my wallet connection to it would have hung up here and shown that it was not connected. Oh yeah, you can see that it lost connection, and I will need to connect to it again. And here it connects to it again. And so the application server, sorry, the web server, I just killed and restarted, and everything recovered beautifully, right? Okay. Now, why did I do this? The reason I did this is to show you that web IBC. So in this little example, I've now got that same encouragement app, and what I did is on the running chain, I killed the host server, but the chain has kept on going. The old instance might still be there, but I have now just added to the chain an IBC protocol that was not contemplated when this chain was built, compiled, and deployed. So it's brand new code doing a brand new protocol that I put together in an ad hoc fashion in JavaScript to be able to send back hellos and my protocol in JavaScript that I implemented. I'm now going to copy my little example code that I used to show it off up here. Let me go to the top. Part of the problem is of making this bigger. And you can find this thing you guys on your own. Let me just grab my example here and go to my wallet here. And actually, you know what? I'm going to go to a wallet. I have multiple users on this system. I'm not just going to go to this wallet. I'm going to go to a different user, because the important thing here. So this is wait, I went to the same user. Hang on. Let me find. Oh, there he is. There's my other user. So here, this is user 8001 instead of user 8000. You probably can't see that. But this user is a different user because, of course, if you're building a web application, you know, the guy who deploys, the Uniswap equivalent isn't the guy he wants trading. It's all the other people out there who come to this web app and do trades against their wallet. So this is a different user with a different wallet. What I have with my wallet is a command line tool. So this lets me act as the user. These are all the base capabilities that the user has access to, including a registry of lots of other applications, etc. And so I'm going to paste this expression. And what this expression is it is taking my, oh, did I go to the wrong guy? Let me go to my other wallet here and see whether his home.ibc port, and I am now sending a message to the, oops, I am sending a message home.ibc port tilde to the on-chain. Aha, his address changed. All right, so I need to use the correct address. So there I am sending a message where this is just JavaScript. Any JavaScript on the planet, I'm uploading it to the website. It's running the secure version of JavaScript that Markham started in the JavaScript Standards Committee and has been driving through into JavaScript for the last 10 years. And I run it on the web app chain, and it's using home as a set. Home here is a set of objects that it has remote reference to that are actually objects on the blockchain. And so what I did is I just sent a message to the IBC port that my web app was given to access the blockchain and ask it, hey, what the heck is your name, right?
Yeah, let me just insert a quick bit of history here. That sending of a message to a remote object where you have JavaScript on both sides and the message just looks pretty much just like a JavaScript message. That is due to the promise design in JavaScript, descends from the promise design that Dean and I had worked on in an earlier language that was designed to support distributed computing. It now is supporting distributed computing, and we're bringing back the support for distributed computing into the JavaScript standards process as well.
Just make sure I'm doing the right thing here, because this has worked plenty of times, but I was not. All right, there we go. Let's see now if it's happier. Well, I did something to break it. Damn it! What you get for doing live demos?
The demo gods, they are fickle.
They are, yeah, and it's because this deploy never completed. So I will need to find out what happened, and we will do another demo at some other point in time. Yeah, so it found the IBC connection. It's just that the deploy never actually quite completed, and so oh, it did. Well, if Michael's listening, he can tell me what I did wrong, but. Michael has been working with Jack on getting the DIBC wiring all up and running, and I'm just failing to connect to it here. We'll just try to refind it again.
Dean, I've been really focused on getting the IBC pipes working,
yep.
And I think I can work with Michael on streamlining this demo a little bit too.
Oh yeah. Aha.
Exception.
Oh, yeah,
we don't need to live debug this, I don't think.
Yeah, fine.
Come on, blockchains are basically debugging with friends.
That's right. So what we're doing, one of the things we're doing is working around specific limitations in the relayer where it's focused on particular use cases, and we're stretching the bounds of that. Michael and Jack have been working ferociously enhancing the relayer with all the other features, and it's awesome.
Yeah. In many ways, we were thinking that this particular session was sort of a dry run for our Ready Layer 1 session, which will hopefully have a smoother running demo by then.
Yeah, I think maybe next time we do this all on one machine, I can I can totally do that, Dean.
Yeah.
Sorry, we were experimenting on you, audience.
Yeah. You know, just also for everyone in the audience, this is sort of like the most dominant IBC demo that is going to exist. You know, the setup and stuff, and like the fact that the protocol works is really cool. And then, you know, the SDK is fantastic for building production apps, and the IBC implementation we have in there is the canonical one that's used even in the Agoric demo. But if you think about an IBC application as essentially specific formats of application data bytes moving over these connections, that really opens up a lot of possibilities. And you can really build really complex applications on top of this really basic infrastructure that we've made. And I think that the Agoric chain in this demo is going to be the coolest way to expose that and show that in a dynamic manner. So yeah, this is sort of our first try at this. So we will be definitely showing this demo many more times, and there will be videos of it. So if you've got any questions, please drop us a line, and we're happy to help out. I don't see any other questions in the chat. I do see a conversation around the value that an Ethereum bridge would bring to Cosmos. Anyone have thoughts on that?
Also, there was an earlier question about token on the Agoric.
Yes,
chain.
yes,
Let me jump back to
that's
that.
a great idea. Yes.
I'm getting an echo here. So the Agoric chain will have a public chain that is the Agoric launch chain that we're not talking about dates yet, but we certainly are all there building towards. The Agoric technology, we are, from a stack point of view, you know, that programming in JavaScript will run just fine, you know, with different consensus systems underneath. But obviously, we are well built on top of Cosmos SDK and Tendermint, and so our testnet is all built on Cosmos SDK and Tendermint, and our mainnet will go out that way as well. But the goal is to be able to run across lots of different infrastructures and have the same abstract computation model running on the web servers. You know, that same code runs on individual machine, run on private chain, consortium chain, public chain across multiple different infrastructures and so forth. And so, you know, interop is the name of the game for Agoric, interop is the name of the game for IBC. And as Markham was saying, there's not going to be one winner. We will all do much better if we make sure that there's multiple winners that are all able to work with each other and cooperate. And so there will be an Agoric token. It will certainly power the Agoric chain. You know, it might be available and useful for lots of other purposes. It will be able to spread across a single uniform Agoric system that's running on different consensus layers, whether it's multiple public or public and consensus. But we're very much of the world that, you know, we would use IBC to bring in all the other digital assets that people are creating on all the other chains, whether it's functional things like, you know, the Oracle stuff that you see in Band, or proof of location, or stable coins from other Cosmos zones. All of those will be things that we want to be able to bring over and party on in JavaScript, and whether that and bring over and have them show up as digital assets in JavaScript, or deploy new app protocols and develop them quickly in JavaScript and then roll them out in Go and Rust and other languages for other chains. All of those are stuff that we want to foster. And so there will be an Agoric token, but it won't be the only one out there.
So one of the things I just wanted to discuss kind of as we come a little bit is just kind of the specific advantage that we see from using the Agoric stack in Game of Zones, and what the challenge is in general with the IBC model is you want to implement these rule sets around mutual suspicion. You know, what tokens, what paths, what links do different users trust? Do they want to interact with? What the Agoric system potentially allows players in games of Zones to do, especially in the sort of third phase of Game of Zones, is to implement dynamic behavior here, and sort of be able to dynamically instrument adjust both on the client side and on the chain side how they're interacting with the rest of the IBC network in an environment where the IBC network is where everybody else in the IBC network is also trying to steal your money. And that I think is like a really sort of powerful capability, and potentially I think is for people who are playing in Game of Zones a reason to spend some extra time taking a look at the agoric stack. There are going to be many ways. I can imagine many ways of implementing sort of successful zones that'll work well in Game of Zones, but I think the agoric toolkit is particularly powerful in this regard.
I'm looking forward to something like this. I'm going to do a just a toy thing, but I showed you that little bit of code, for adding the IBC stuff into our little app encouragement thing. Well, it's JavaScript. Let me just go ahead and throw in this. If the incoming bytes has the word attack somewhere in it, then throw an exception, right? Imagine whatever it is your filter function is that you had. If the transfer message has a negative number in it, then I'm going to filter it out. If the transfer's message is from Joe, because Joe, man, he's been beating me up, I'm going to filter it out, right? If being able to add JavaScript and rapidly deploy a new contract that has interesting more plumbing to be able to help with analysis, wiring, and attack or defense in Game of Zones, I hope will be very useful to people. Back to you, Zaki. Sorry.
Yeah. No, I mean that's exactly why we put this session together, to kind of show things off. I think that the Cosmos SDK is very useful for building sort of very reliable, fairly stable, very predictable state machines. But it's super cool to see the maturation of the ideas behind Agoric and being able to sort of take that framework and adapt it to doing something so much more dynamic. And I'm pretty excited about sort of post IBC, the sort of money Legos on Cosmos manifesting. Yeah, it's sort of this. It's a very, very cool framework, and it's a very cool set of tools that we're sort of providing to the world and providing to this multi-chain world. And yeah, I think that's like kind of a major theme of 2020 in general, is just blockchain developers getting a bunch of really cool new toys, sort of all at once across many different blockchains, and that's really exciting. Foundation for things sort of evolving.
You realize after Ready Layer 1, we're gonna have to do Ready Layer 2.
Is Layer 2 ready? It's a good question.
Well, it's after Ready Layer 1, so
Okay, but how long
let's get IBC first, and then we'll talk about that. What? Yes.
How long is it going to take us to get to Ready Layer 8? Because there's a lot of layers in this OSI model, and I just don't know if we're prepared for this.
I think Layer 8 is when we've spawned AI children, and they're now running the economy for us. So I'm perfect. I'm not in a hurry for that one.
Okay. I was looking forward to AI raptors, maybe puppies, but
well, the other worry is if you look at the ISO stack, Layer 8 is the political level. So I also am not looking forward to that one. So let's stick with governance, which is easier.
Yeah. Let's stay with governance.
Yeah, cool.
Thank you all for your time. This was great. Yeah. Sorry, I didn't manage to get my demo all the way working through.
It's awesome. It's cool to see all this stuff come together.
Well, the other thing is with the relayer, what Jack and Michael are working on. I'm gonna squeal on you. That command that he would say to send a message, it will be able to send a packet in a particular contract, or you can just paste a packet, so it's easy to do manual debugging, and then you could paste it and it ends up in JavaScript, and the JavaScript parses it and responds. And so being able to have dynamic stuff on either end, one way or the other, is going to be really nice for being able to put together shell scripts to do stuff in Game of Zones, to put together programs, etc.
Yeah, I've really tried to build the relayer to be as command line user friendly as possible for folks using command line tools to do this. And we've used it to integration test and debug the entire time we've been building IBC. So it is really built as a dev tool. So if you need to do any kind of dev tool-y type stuff with IBC, all of that stuff lives in the relayer. There are affordances. There's probably even aliases for it, and you can type them in super short hacker type if you want, like I like doing.
Yeah, we saw you abbreviating an awful lot of stuff there.
It's yeah, you know, I like being able to abbreviate stuff, especially in command lines. I think it's really nice, you know, having those full names like connection and channel and being able to abbreviate them. It's just makes for a fun tool that people like to come back and use.
All right,
So,
folks.
thank you, everyone.
Yeah.
Oh, and there was one more question that you said before we abandon everyone. There was the one more question about the Ethereum bridge.
Sure. Yeah, we could talk a little bit about it.
So actually, I wanted to come back to something about that, because when Jack first brought up clients versus connections, one of the things that we drove into the standard in June, and is really the difference there, is the client is the thing that knows how to be the client and talk to the other side. But important thing about Ethereum is, you know, how connected you are. What it means to be connected depends on what your threshold, what your finality threshold is. And so in some sense, an important difference is the client is following the chain, that, you know, the set of things that it's able to follow in terms of the proof of work, but the connection is looking at that, where the block headers on the chain might be out here, but the connection is only willing to believe the blocks that have, you know, 10 blocks after them. And so your connection is following to show, here's what I actually believe I'm seeing as real packets, as opposed to here's what's kind of up there in the, you know, in the process of being, you know, still proving itself in the proof of work mechanism. And so, you know, so clients, you know, being able to do an Ethereum light client is, you know, the specification is designed for, even if it's not implemented. One can then produce multiple different connections at different threshold levels, depending on the assurance you need for a particular set of use cases. And on top of those connections, you then do channels that are relying on the finality of the underlying connection you chose to use. And then if there's like, if you said I only need 4 levels of finality, and there's a rollback that's deeper than 4, your 4 levels of finality connection will break.
So
yeah, it's very nice that Ethereum's roadmap has them switching as a consequence of the switch to proof of stake, switching to a system that supports finality. But of course, Bitcoin never will, and we want to be able to peg both of those to manipulate them from our infrastructure. So we have to deal with 9 final chains, and we will through this plan. But we're definitely friendlier to chains with finality.
And on Monday at 8 a.m., just to hype more stuff, Gavin at Figment with the folks at Althea and the Cosmowaza folks, and I'll be there. We have a conversation about sort of the post white paper, post IBC Cosmos roadmap, and sort of atom holder value accrual. And, you know, one of the big things that I think is a very exciting sort of post IBC thing is that you could actually have multiple abstractions between Ethereum. Like, you know, I think there's been this notion of like the one true canonical Ethereum bridge. But that is not how I think IBC is actually going to work out. I think IBC interacting with Ethereum is going to be, you know, there's going to be some places where things are just sort of moving tokens between the two systems. There's going to be other sort of more like sort of economically rich functionality, like what Althea has proposed, where you sort of have a smart contract on the Ethereum side plugged into a validator set on the Cosmos side, and IBC sort of enabling an interaction there, but also, for instance, the governance on that of that validator set, you know, putting assets into DeFi applications on the Ethereum chains. It's quite complex, the worlds that we can now create in sort of this post IBC world.
Mm-hmm, mm-hmm. So build more tools for us.
Yes,
you will need them.
Cool. So I think we're ready to sign off.
Excellent.
Yeah. Just
Thank you all. Thank you for having us, Zaki, Jessy, Jack.
Just a quick reminder, we're closing registration for Game of Zones on Saturday. So if you haven't signed up, make sure that you get in.